So today we're going to talk about the arithmetic sequences. What are arithmetic sequences? An arithmetic sequence is a sequence whereby for you to find the next value in a pattern, in a sequence, you are going to add the previous value by some constant value throughout. What do I mean by that? I mean that if you have 2, 4, 6, 8, to go from 2 to 4, you will add a constant value called the second difference. Now the difference here is 2. You will add 2 to get 4, and to get the next value you will add 2, and to get the next value you will add 2. So even to get the fifth term you will add this constant value, and we call this the common difference. We denote it by D. Now, arithmetic sequence is the one where we find that the first difference is constant. So the difference between each consecutive number will be one constant value. Now, how do we find this constant value if you are not given? It's simply by taking the following value, subtract the previous value, and you get your common difference. So to find D, you will take some value and then you will subtract it by the previous value, which is n minus 1. And by n, I mean the position of the value. So if you have t3, your n is 3, so you'll take the value at position 3 subtracted by n minus 1. So that will be 3 minus 1. So the n has to be the same. Every time you use any formula while doing sequences, patterns, and series, when you substitute into one equation, the n must be constant for all n's. Now 3 minus 1, that means we'll take the value 2. So you see t3 minus t2. You take the following value subtracted by the previous value, and you get your common difference, which is D. And that's how we identify an arithmetic series. Before we continue with examples, let's just talk about the notation we are going to use for sequences, patterns, and series. Now, if I have my sequence here, the position of the value in the sequence, we are going to denote that by n. So the position in sequence will denote it by n. So this will be n equal to 1. This will be n equal to 2. N equal to 3, n equal to 4, so forth until some value at the end of the sequence where n will just say is equal to n, because we don't know the position of that value. So the position in our sequence, we will denote it using n. Now, when we say Tn, the Tn is the value of the term itself. Now, if we want T3, N3, N equal to 3 will be position 3. So we know that T3, which is our Tn, our value at some position, will be 9. Now, remember, n is the position. So when you see 3 here, you will go to that position 1, 2, 3 and find that value. So our Tn is our nth term. So T3 will be our third term. So this gives us the position, and T, that position gives us the value there on that position. I ran out of space. Let's just come here. We'll also use D to denote the difference, the common difference in arithmetic sequences. And we say that we find that one by taking Tn minus 1. A lot of people like n plus 1 minus Tn, but I find it interesting to use this one. Don't worry about this one when you are listening to me. Now, this will be our common difference. And this plays a big part in identifying arithmetic sequences, because as soon as you find the difference between each value and you find that the first difference is common, you will know that we are dealing with arithmetic sequences. If you do not find that the difference are common, it is a constant value, then you know you are not dealing with arithmetic sequences. Maybe if you continue to find the difference of the difference and you find that it's constant, then you will be dealing with a quadratic, which we'll deal with later on. And that is the notation we are going to use. To identify arithmetic sequences, you are going to find the difference in these consecutive values. And if that difference is constant, it is the same value, then you know that you have an arithmetic sequence. Now, that difference we said we note it by D, and it's given by taking a value subtracted by the previous value, which is Tn minus 1. Let's take Tn, which is T2, minus T2 minus 1, which is T1, minus 4. So our first value will be minus 4, subtract the previous value, which is minus, we subtract 2. So we get minus 6. Now, if we keep going and we check if minus 10 subtract the previous value, which is minus 4, gives us 10 plus 4, minus 10 plus 4, which is minus 6. As you go on, you will find that this is also minus 6. So when the first difference of your sequence gives you a constant value of D, then you know that you are dealing with an arithmetic sequence. This first common difference, as soon as you start and your first difference is constant, then it is an arithmetic sequence. The first value of each sequence, whether it is arithmetic, we should have noted this when we were talking about notation, is A, which is the first term of the sequence. So term 1 we denoted by A. T1 is A. Now, let's say we have our T1, which is A, is equal to 12. And we have a common difference of minus 6. How do we find term 2? To find term 2, we will take, remember, to find the second term, you add the common difference. So we said if you have 2, 4, 6, from this value to get to the following value, we will add 2. To get to the second value, we will add 2. But for us to find the common difference, and difference means subtracting two numbers. So to find this value that you need to add, we do it by taking this value and subtracting it to this one. So T2 will take it by taking the first value and adding our common difference D, and then we will get 6. Let's find T3. T3, we will take the previous value, which is 6, plus our common difference, and we get 0. We can keep going on. T4, our previous value, not A, our previous value 0 plus our common difference, which gives us minus 6. Now, let's do this using notation. T1 is equal to A. Now, to find T2, we take A and add our common difference. The same thing that we did here by taking that common difference to get the following value. To get T3, we will take our previous value, which is T2, and add the common difference to find T3. So A plus D, we add our common difference, which is D, and then we will get A plus 2D. Now let's keep going and find T4, our fourth term of our sequence. We will take our previous term again, A plus 2D, and we will add our common difference, and that will give us A plus 3D. Just for effect, let's find T5. T5, we take our previous value again, A plus 3D, plus our common difference, which is, it will give us A plus 4D. An interesting pattern that you will see with this arithmetic sequence is that when you are looking for T5, just using the notation, our T5, our 5, you will get A plus 4D. Always this value will be one less than the position of the term. If you want T4, you will get A plus 3D. A plus 3D. 3 is one less than the position of your term. Now, I want us to take that same idea and apply it to here where we made an example and say, we know that T1 is 12, and we say that our first term is denoted by A. Now we want to find T4 using this principle. Now to find T4, it will be given by A, just like the pattern we saw here, plus one less than the term, the position of the term. So if we are looking for T4, we will have 3, which is one less than 4. So it will be given by A plus 3D. Now let's substitute using these values. We know that our first value will be 12 plus 3 into our common difference, which is minus 6. So 12 minus 6 times 3, 18. 12 minus 18 will be minus 6. So you can see that our T4 is the same as here. So how do we know this so that we can use it even for term 100? In an arithmetic, we know that term 100, you'll find it using A plus 99D, one less than the position of the term. But what about Tn? What about the nth term? We don't want to give it a numerical value, but we know that we want the nth term. So n here, we want to substitute the position with n, not an actual value. To find Tn, let's put it closer so that we can see. To find Tn, as we agreed, as we found out with all the examples we've done so far, we are going to take the first term, A, which is the first term, and we're gonna add it by one less than the position of the term. So if the term is n, then we are going to add it by n minus 1d. Because so if this is 100, then it will be 100 minus 1, which is 99. If it is 5, then it will be 5 minus 1, which is 4. So T5 will be 8 plus 4D. Always 1 minus the position of the term. And this is the formula for the arithmetic sequence. The first term plus the position of the term minus 1 multiplied by the common difference. This formula that you see here, we call this the general term, the general formula for the nth term. Let me write that down. This is the general formula for nth term. So if they ask you to find the general formula, they mean that find Tn. Find the formula when our position is not specified. Now our n will be the position of the term. Tn will be the value of the term. A is our first term of the sequence. N plus 1 is just taking the position. Subtracting 1. And then D will be the common difference. And we know we find the common difference by taking our sequence 1, 2, 3, 4 and then subtracting value with taking this value, subtracting the previous value to get our common difference D. Now let's take an example. Let's say we are given minus 15, minus 11, minus 7, 173. Now you will see this a lot to show you that there are terms that it continues all the way until this value. Our sequence, you see a full stop there to say, okay, it ends here. But if you have this, usually 3 ellipses, it shows you that it continues, and then I'll give you the last term there. Now, the first question they could ask is this an arithmetic sequence? Now, how do we find out that it is an arithmetic sequence? Remember that for an arithmetic sequence, the first difference will be common. You will find the first common difference. It will be constant. So how do we prove that? We'll find that 11 minus negative 15 gives you, that is positive, so it will give you 4. Minus 7 minus 11 will also give you 4. So because these two are equal, you start to see the pattern that, okay, the first difference is the same. So yes, it is arithmetic because the common difference is constant, and our common difference in this case will be 4. Now, another thing they could ask you is determine the general formula for this sequence. Remember, for arithmetic sequences, to find the general formula, it is Tn, the nth term, equal to A, the first term, plus n minus 1, which is the position of the term you selected, minus 1, multiplied by the common difference. So if they say find the general formula of this sequence, you are looking for Tn. You are looking for this. Now, let's just make it more pretty for us to see. Every time I introduce yellow, it seems things look so official. Now, what is our first term? Our first term is term 1. So A is negative 15. We put that in our formula, and then remember we are looking for Tn. Our first value is minus 15 plus, what is our n? Our nth term. Since we are looking for Tn, that means we will keep the n here. Unless I put T4 here, then I will put 4 here. But unless I do that, our general formula, we're just looking for a general formula for the nth term. So we do not care about the actual position for now. Minus 1, and our common difference, which is 4 in this case. So we can simplify this by multiplying n minus 1 by 4 and get minus 15 plus 4n minus 4. So this multiply this, and this multiply this, and then we get 4n minus 19. That is our general formula for the nth term. You can check it. Look for position. This is position 1, position 2, position 3. Let's use our formula to find position 3. Position 3 will be T3. So 4 multiplied by 3 minus 19. So 4 times 3 is 12 minus 19, and you will get negative 7. You see that our general formula works. They could say to you, how many terms are in this sequence? They ask you how many terms are in this sequence. So if this is term 1, term 2, term 3, term 4, 5, 6, 7, 8, 9, 10, to whatever this last term is, our n. If we find out what number n this last term is, then we will know how many of them are there. Because if this is position 10, then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we find the position of the last term to know how many terms are in this sequence. So remember that this term in itself is T some position. So Tn is this. So in this case we are looking for 173. So this is 173. And then for, we don't know the position. Actually, that is what we are looking for. So Fn minus 19. So we just simplify here.